Alright, Unit 4 exam review. The quadrilateral hierarchy. You gotta know this one. Starts off with quadrilateral. From there, it branches down to trapezoid on one side and kite on the other side. Underneath trapezoid, you have isosceles trapezoid, which I'm going to abbreviate as isotrap, and parallelogram, because they both have at least one pair of parallel sides. Underneath parallelogram and isosceles trapezoid, we have a rectangle. And underneath kite, we have a rhombus. And underneath everything is a square, because a square is every other type of quadrilateral. Check it out when you're done, including the word quadrilateral. You should have 8 total things, and I do. Number 2, consider this polygon. Name a pair of consecutive sides. Consecutive sides touch. So there's obviously lots of different choices. I'm going to start with HI. HI is a consecutive side with IJ. They touch. They come together at a point. They come together at a vertice. True or false? H and K are consecutive vertices. They come right after each other. Yep, they do. So that is true. They are consecutive vertices. They're connected by a segment. Name the diagonals of the vertex. Diagonals connect vertices through the segment, so we would have 2 of them, KI and HJ be our diagonals. Number 3, the measures of the angles of a triangle are given in this ratio, and we want to find the largest angle. If you're given a scenario like this, you just take each of these numbers and put an x next to them and add them. 2x plus 3x plus 10x, and you should recall that the measures of the angles of a triangle add up to 180 degrees. I add up my x's. I have a total of 15x here equals 180. 180 divided by 15. I'm going to solve for x by dividing by 15. 180 divided by 15, we find x equals 12, because 180 divided by 15. That's not our answer, though, because it wants the measure of the largest angle. The largest angle would be 10 times x, 10 times 12 in this case, which would be 120 degrees. For number 4, oh, this is a good one. First thing you have to do is figure out, well, this is a hexagon, so what is the sum of all 6 angles in a hexagon? You have to recall the formula n minus 2, where n is the number of sides, times 180. In this case, we have 6 sides, so this is 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180. You have a total in a hexagon of 720 degrees. So these 6 angles have to add up to equal 720 degrees. And then we're going to make a big, long equation, which I'm going to do right here and see if I can have room for it. I'm going to start with h. It's a 90-degree angle. I add that to 130. I add that to, that looks to be 4c plus 15 plus 6c minus 20. I'm just going through my angles and writing them down. Plus 6c plus 1. I just had to come down here. Plus 120. And all of that equals 720 that I had found previously. Okay, so now I'm going to combine my c's. I have a total of 4c plus 6c is 10c plus another 6 is 16c. So I have a total of 16c. And then my numbers, my non-c's, I have 90 plus 130 plus 15 minus 20 plus 1 plus 121. Total of 337. So 16c plus 337 equals 720. All I did was simplify all this to make this right here. From here, I'm going to subtract 337. So that will give me 16c equals, and then 720 minus 337 is 383. And finally, to solve for c, I divide by 16. 383 divided by 16 is 23.9375. And then finally it wants angle G. Well, we know that angle G is 6c plus 1, so I'm just going to punch in 6 times 23.9375 plus 1, and I get an angle measure of 144.625 degrees. Number 5, not as long, thank goodness. We want an angle of AMR. That's this external angle. In order to find that, I need to find this internal angle because I know these 4 angles inside my quadrilateral add up to 360. So I'm going to do 360 minus this 90 degree angle, minus this 82 degree angle, minus this 76 degree angle, and I get this angle right here to be 112 degrees. That is this angle inside. And that forms a linear pair with AMR, so to find AMR, what we want, I just do 180 minus 112, which is 68 degrees, and that is your answer.